Chapter 2, Atoms and Atomic Structure. Matter. It is defined as anything that has mass and occupies space. Everything in universe is made up of matter. Mass. The amount of matter contained in a body is called its mass. Weight. The force with which a body is attracted towards the center of the earth is called its weight. Classification of matter. Matter, it is classified as element, compound and mixture. Element. An element is a simple substance which cannot be further divided into two or more substances. Elements are divided as metals and non-metals. All metals are solid except mercury. All non-metals are solids or gases except bromine, which is a liquid. Chemical symbol. It is the abbreviated form of the name of element such as iron Fe, oxygen O, copper Cu, silver Ag, aluminium Al, etc. Mixture. A mixture is a substance that contains two or more elements or compounds. Air is a mixture of oxygen, nitrogen and other gases. Mixture are of two types: homogeneous mixture and heterogeneous mixture. Homogeneous mixture. This mixture has a uniform composition throughout its mass. A mixture of sugar dissolved in water is a homogeneous mixture. Heterogeneous mixture. A mixture having different composition throughout the mass is known as heterogeneous mixture. A mixture of sand and cement is an example of heterogeneous mixture. Compound. When two or more elements combine chemically in a fixed proportion, they form what we call as compound. For example, when hydrogen and oxygen combine in a fixed proportion, they produce water, H2O. Law of chemical combination. There are certain laws which govern the chemical combinations of substance. These are called law of chemical combination. These are: first, law of conservation of mass. In a reaction, the total mass of reactant is equal to the total mass of product. It means matter can neither be created nor destroyed. This is also known as law of indestructibility of matter. This law was first established by Lavoisier in 1785. Law of definite proportions. When elements combine to form compounds, they do so in definite proportions by weight. A compound always has the same proportions by whatever method it is prepared. Water from lakes, seas, wells or rain has the same proportion of hydrogen and oxygen. This law was given by Joseph Proust in 1799. Third, law of multiple proportion. When two elements combine to form more than one compound, the different weight of one of the elements combined with the fixed weight of the other bears a simple ratio to each other. The law was proved by Berzelius and Stats. Law of reciprocal proportions or law of equivalent proportions. The weight of two elements combining separately with a fixed weight of a third element to do so with each other in multiple ratio. Dalton's atomic theory. One element are made of minute indivisible particles called atoms. Atom can neither be created nor destroyed. Third, atoms of the same element are in same in all respects such as mass, size, etc. Fourth, atoms of different elements are different. Fifth, compounds are formed by the union of two or more atoms of different elements. Sixth, when atoms combine to form compound, they do so in simple ratios such as 1:1, 2:1, 2:3. Seventh, compound atom is the smallest particle of a compound. 8. Compound particles of the same compound are alike in mass and size but differ from other compound. Atoms. It is the smallest indivisible particle of an element. What can take part in a chemical reactions? Molecule. A molecule is the smallest particle of matter which can exist freely. Atomic weight. Atomic weight of an element is a number which indicates how many types its atom is heavier than an atom of hydrogen taken as unity. For obvious reason, the standard was shifted from hydrogen to oxygen. Oxygen was assigned a value of 16 units. Atomic weight of an element is the number of times its atom is heavier than 1 upon 16 of an atom of oxygen. This is called physical scale of atomic weight. This made the atomic weight of hydrogen 1.0080. In August 1961, the oxygen standard used in computing atomic weight was officially replaced by the present standard of 12.000 units. For the carbon-12 isotopes, now 1/12, the part of mass of carbon-12 is taken as unit for atomic weight and it is called AMU, atomic mass unit. This carbon scale is known as unified scale. One atomic mass unit is equal to one atomic mass unit equal to 1/12 the part of mass of carbon-12 equal to 1.67 10 raised to minus 24 gram. In recent year, AMU is replaced by the letter U. U refer to unified scale of atomic weight being used now. Absolute relate to atomic weight of some elements. Element helium relative atomic weight AMU is 4.0026. Absolute atomic weight in gram is 6.65 multiplied by 10 raised to minus 24. Iodine AMU value is 126.91. Atomic weight of absolute in gram is 211 10 raised to minus 24 of iodine. Gold relative atomic weight of gold is 197.00 AMU. Absolute atomic weight of gold is 317 10 raised to minus 24 gram. Relative atomic weight can be converted to absolute atomic weight using the conversion factor 1 AMU equal to 1.67 10 raised to minus 24 gram. Absolute atomic weight is equal to relative atomic weight multiplied by 1.67 10 raised to minus 24 gram. Molecular weight. It is the number of times the molecule is heavier than 1/12 of carbon-12 atom. Molecular weight is equal to weight of molecule upon weight of 1/12 of carbon atom equal to 12. Gay-Lussac law of combining volume. Whenever gases combine, They do so in volume, which bears a simple ratio to each other, as also to the volume of the products formed. If gases provided or volumes are measured under the similar condition of temperature and pressure, this is also known as the law of gaseous volume. Berzelius hypothesis. Equal volume of all gases under the similar condition of temperature and pressure contain equal number of atoms. Avogadro hypothesis. Equal volume of all gases under the similar condition of temperature and pressure contain the equal number of molecules. Application of Avogadro hypothesis. 1. Avogadro hypothesis is useful in determining the atomicities of elementary molecule and the formula of compound. 2. To obtain the relation between vapor density and molecular weight of a substance. Avogadro number n. The number of atom in gram atom is called Avogadro number. Its value is 6.02252 10 raised to 23, which we approximate as 6.023 10 raised to 23. The mole. A mole is defined as quantity of a substance which contains the same number of particles as are present in 0.012 kilogram, 12 gram of pure carbon 12. Alternately, moles is the quantity of substance that contains 6.023 10 raised to 23. Particle may be atoms, molecule, electron, etc. Mole concept can be used to calculate number 1. The absolute weight of single atoms of an element. Weight of one atom GMW upon Avogadro number n. Second, the absolute weight of single molecule. Weight of one molecule is equal to 1 GMW upon n. Number of particles in the given substance. Number of atom is equal to number of JAW multiplied by n. Number of molecule is number of JMW multiplied by n. The volume of gases or mixture of gases at STP is equal to 22.4 liters. Chemical equation. A chemical equation represents a chemical reaction with the help of symbol and formula of reactant and product. Reactant, the substance which take part in a chemical reactions, are known as reactant. Product, the new substance produced as a result of chemical reaction, are known as product. Balanced chemical equations. Balanced chemical equation. A balanced equation has an equal number of atoms of different elements of reactants and products. Unbalanced chemical equation. An unbalanced equation has an unequal number of atoms of one or more element in reactant and product. Balancing of a chemical equations. The process of making the number of different type of atoms equal on both the sides of an equation is known as balancing of an equations. There are two methods of balancing the equation. One by heat and trial method, second is by partial equation method. States of method. There are three states of method. 1 solids, 2 liquid and 3 gases. Solids. Solids have definite shapes and volume because atoms and molecules are closely packed in a systematic way. Each atom and molecule has a fixed position and not free to move. Example books, chair, copper, wood, etc. Second, liquid. In liquid, molecules are close to each other. This is why liquids have definite volume, but molecular arrangement in liquid is different from atoms. Molecules in a liquid are free to move. That is why liquids are fluids and can take shapes of the container. Example water, milk, etc. Solid state where atoms are consistently arranged in a unified manner. In liquid states, atoms are far away from each other. They are not definite and unified in arrangement. They are irregular in their positions. 3. Gases. Gases have neither a fixed volume nor fixed shapes. The molecules remain far apart from each other and are free to move because of weak intermolecular forces. Gases fill the container, example oxygen, nitrogen, air, etc. What a bottle of perfume is open, it spread in the whole rooms.